One of the most anticipated astronomical events is the Betelgeuse Supernova, located on the famous shoulder of Orion. Betelgeuse is a red supergiant star nearing the end of its life. Strangely, in 2019, Betelgeuse, one of the brightest stars in the sky, began to fade. The fading was so noticeable that it could be seen without special optics for a few months. Betelgeuse dimmed, prompting observers to wonder if the star had died. When scientists focused their most powerful telescopes on this red giant, they were shocked to see evidence of the great dimming, even though the star's brightness had returned to normal after a few months. As Betelgeuse's life cycle nears its end, it may soon explode in a supernova. When and why might a supernova occur, and will it have catastrophic consequences for Earth? Let's look into it. The brilliant ruby-red star Betelgeuse is located on the upper right shoulder of the winter constellation Orion, also known as Alpha Orionis. It's the second brightest star in the constellation, directly behind the blue supergiant Riel. Betelgeuse's variable behavior and unique name make it an interesting target for astronomers. Alpha stars are usually the brightest in their constellation, although Riel is brighter due to its characteristics. With its name, brightness, size, and reddish hue, Betelgeuse or Alpha Orionis is one of the most famous stars. It's the 10th brightest star in the sky and the 7th brightest visible from North America, Europe, and Canada. Betelgeuse comes from an Arabic term meaning the armpit of the giant, a frequent interpretation. Its actual distance from Earth is uncertain, with estimates ranging from 430 to 724 light-years. In simple terms, Betelgeuse is the brightest and closest red supergiant to Earth. Only about 200 red supergiant stars are known to exist in the Milky Way. Betelgeuse is 16 times the mass of the Sun, emits 126,000 times as much light, and is visible from a distance of 548 light-years. With a surface temperature of 3,600 Kelvin, Betelgeuse is cooler than the Sun, and only about 13.3% of its radiant energy is visible light. Betelgeuse would outshine Sirius if we could perceive light across all wavelengths. It is estimated to be 764 times the Sun's diameter. If it replaced the Sun, its influence would extend past Jupiter, engulfing Earth, Mars, Mercury, and Venus. This red supergiant loses about one solar mass every 10,000 years as material is ejected unevenly in all directions, creating a nebula around it. This nebula spans roughly 30 astronomical units or 30 times the distance between the Sun and Earth, about 250 times larger than Betelgeuse itself. At its core, high hydrogen atoms fuse under intense gravity, creating helium in a nuclear explosion that releases heat and light. This energy travels to the star's surface and is discharged as photons into space. When hydrogen depletes, the star relies on helium and carbon for fusion. As it exhausts helium, carbon fuses to form iron. The fusion of neon and iron absorbs energy, which the star requires for stability. As iron builds up, the star collapses under its own gravity, triggering a supernova with the power of 10 billion suns, one of nature's most powerful explosions. Stars emit light of different wavelengths based on their age and stage, producing colors from blue, young, to red, old. Greek scholar Ptolemy described Betelgeuse as reddish, while ancient Chinese astronomers saw it as yellow, suggesting it may have once been a yellow supergiant. Larger stars consume hydrogen faster, ending their lives sooner, even if only 10 million years old, while our Sun is over 5 billion years old. Betelgeuse is in its last phase, so it could explode in a supernova, although the timing is debated. The star experiences 2 cycles of dimming and brightening, with one lasting about 100 days every 5 years. Betelgeuse's erratic dimming in 2019 and 2020 attracted attention, with some speculating it signaled the star's death. Observations of Betelgeuse date back to the 1st century BC, yet the cause of its sudden dimming remains unknown. Betelgeuse was observed traveling through space at 30 kilometers per second after leaving its home in the Orion OB1 association, which includes stars in Orion's belt. The shock spans over full light years. Measuring distances to red supergiants like Betelgeuse is challenging in astronomy, as various factors affect its diameter. Calculations. Betelgeuse's apparent size changes due to its pulsation and limb darkening, where visual dimming occurs at the edges. Estimating its photosphere requires accounting for the circumstellar envelope, which emits and absorbs light. Observed diameters may vary by up to 35% depending on the wavelength used. In July 2009, the European Southern Observatory's Very Large Telescope Interferometer captured a massive gas plume extending 30 astronomical units from Betelgeuse. This is one of multiple mass ejections, with a size equal to the angular separation between the Sun and Neptune. At least 6 shells have been observed surrounding Betelgeuse. Understanding mass loss in dying stars may reveal the cause of their eventual collapse. Betelgeuse's vast atmosphere and intricate dynamics pose questions, and while the mechanism behind mass loss in red supergiants is unknown, it's essential to recycling matter that forms galaxies. Recent advances in interferometry may help solve this mystery. Researchers using the Hubble Space Telescope and others found that in 2019 Betelgeuse ejected a large chunk of its surface in a major surface mass ejection. Unlike common coronal mass ejections from the Sun, this event involved Betelgeuse expelling 400 billion times more mass, leading to its rapid dimming from October 2019 to mid-February 2020, when brightness fell from magnitude 0.5 to 1.7. By February 17, Betelgeuse's brightness had stabilized, and within 5 days, the dimming had ceased, effectively ending the event. The recent dimming appears unrelated to the anticipated core collapse, as no significant changes in its core were detected. On February 24, 2020, a study concluded that large circumstellar dust grains likely caused Betelgeuse's dimming. Using submillimeter wavelength measurements, the study ruled out dust absorption as the main contributor, with large star spots believed to be responsible for the fading. Detailed observations revealed that Betelgeuse's luminosity had dramatically increased, and the recent drop in brightness was linked to a second dust cloud emerging from the star. By August 30, 2020, a cold region on Betelgeuse's photosphere was hypothesized to be the dust source. Another examination confirmed this in June and August, suggesting that cooling gas ejected by the star formed the dust cloud. Studies from the Hubble Space Telescope in 2022 supported that material ejected millions of kilometers from Betelgeuse's surface had cooled and compacted, forming a cloud that obscured the star from Earth's view. The dimming, which started in late 2019 and lasted a few months, was even visible to backyard stargazers. In a striking development, Betelgeuse's 400-day pulsation cycle ceased, leading astronomers to monitor its surface motions and brightness variations for clues. The force of the disturbance hints at a large surface mass ejection, an event previously undocumented, which caused the star's photosphere to break apart and fall into space. This phenomenon provided valuable insight into how red stars lose mass before running out of nuclear fuel and eventually exploding in a supernova. The star's photosphere appears to be rejuvenating, while its internal structure vibrates like a ringing bell, indicating disturbance in its natural cycle. Betelgeuse's recent behavior, although unusual, does not necessarily signal an imminent explosion. Experts noted that surface mass ejections in massive stars are a newly observed phenomenon, indicating a mystery yet to be fully understood. Hubble has enabled real-time observation of these unique surface events, with the ejected material's infrared radiation detectable by NASA's James Webb Space Telescope. Betelgeuse's dimming has now stabilized, possibly returning it to its former status as the 10th brightest star in the night sky. Despite its great distance, Betelgeuse shines at nearly 100,000 times the sun's brightness, rapidly burning through its fuel, which hastens its destruction. When the star finally runs out of fuel and collapses, it will explode into a spectacular supernova, becoming extremely bright for several weeks or months, possibly even as visible as the full moon. Though uncertain, this event could happen at any time, from tomorrow to millions of years in the future. Earth, however, is not in danger from a Betelgeuse supernova. The star's distance ensures that life here will remain safe, as a supernova's harmful effects diminish beyond 50 light-years, and Betelgeuse is over 10 times farther away. Instead, Earth will be treated to an extraordinary show as this very bright star suddenly appears in the sky.